If you've seen the two previous videos on limits and the limit definition of the derivative, an example, then we're ready to go on and try some harder problems involving using the limit definition to find the derivative. So let's find f prime of x using the limit definition. And let's do that for the function f of x, which looks like square root of x plus 5. Well, let's start off by writing down the definition of f prime of x. It is the limit as h goes to 0 of f of x plus h minus f of x, and that's all over h. So we've got the limit as h goes to 0, and let's start by calculating f of x plus h. So we're going to go back to our original function here. Here's our f of x, and let's replace every x that we see with an x plus h. So that gives us square root of x plus h plus 5. Okay, and then we'll subtract off our f of x. So our original function was root x plus 5, and that is all over h. Now at this point, if we tried plugging in h equals 0, we just have an expression that's undefined because we can't divide by 0. So that suggests that we have to do some more algebra to solve the problem. Now when our function f of x has a square root in it, there's a specific trick that we need to get this simplified. What we're going to have to do is multiply the numerator and the denominator here by what's called the conjugate radical. Okay, so let's throw some brackets around this, around the numerator here, and we're going to multiply top and bottom by this exact same expression that we've got in the numerator. The only difference is that the sign in the middle here is going to change. So we're going to make it root x plus h plus 5, and we're going to change that sign in the middle to a plus sign. So it's going to be plus root x plus 5. And we want to multiply numerator and denominator here by the exact same thing. So we'll just recopy that again in the denominator. Okay, and just for clarity, I'm going to throw brackets around the numerator and the denominator here just to help us with our calculation in the next step. So this guy here, as I mentioned before, he's called the conjugate radical. So whenever our function f of x involves a square root, we're going to have an expression like this that has two different roots in it. And the conjugate radical is what you get just from recopying this original numerator and change the sign that is in the middle. So our negative sign here becomes a plus sign, and we just multiply numerator and denominator by that conjugate radical. So by multiplying here top and bottom by this quantity, we have not changed our original function. It just looks slightly different, but with a little bit of algebra, we'll see that this is the right thing to do to get our simplification going. So now in our next step, we're going to have to expand out this numerator. But if we take a step back and just think about what's going to happen here, it might save us a little bit of algebra. If we check out what's in the numerator, we've got this funny square root here, another funny square root. So let's just call these guys maybe a and b. So we've got a minus b in that first bracket. And if we take a look over at the second bracket, we've actually got the same a and b quantities coming up, same quantities as in the first bracket, but just with a different sign in between them. So the second bracket in the numerator is really a plus b. Okay, so I've just called them a and b for short, just to see what's going to happen when we start to expand out this expression. So if we were to FOIL this out, you might already recognize it's going to be just a difference of squares. We're going to have a squared, and then we'll have plus ab, minus ab, and then minus b squared. So a squared minus b squared, just our usual difference of squares formula. So if we think of it this way, in our next step, instead of expanding out this big expression that involves the square roots, we could just say, well, we're going to get the limit as h goes to 0 of this first quantity, this a squared, so square root of x plus h plus 5 squared. And then we're going to have minus our second quantity squared. So minus root x plus 5 all squared. Okay, so that's the fast way of thinking about it. Of course, if you wanted, you could take another step or two to actually FOIL this out and simplify if you prefer to do it that way. Now in our denominator, we've got h times, and then we've got a copy of our conjugate radical. So times root x plus h plus 5, and then plus root x plus 5. All right, so looking good so far. We still have an h in the denominator, so we've still got a couple more steps to go to really get this simplified. So we're looking at the limit as h goes to 0. And if we square this square root here, we're just undoing that square root. So we got x plus h plus 5. And then we are going to subtract off everything that we get from the second term. So not a bad idea to put brackets on there. We need this negative sign to distribute across. So we really do need the brackets, in fact. And the square here is just going to undo the square root like before. So we've got negative times x plus 5. All right. In our denominator, we'll just recopy this. We've got h times our conjugate radical. Okay, so on to our next step. We're looking at the limit as h goes to 0. And let's finish just expanding out this numerator. Got x plus h plus 5. And if we're careful about our signs here, we got minus x and minus 5. And that's all over h times our conjugate radical. All right, so we get a little bit more cancellation now in the numerator. The x and the minus x are going to cancel. The 5 and the minus 5 are going to cancel. And that leaves us just with a nice h in the numerator. So we've got h over h times our conjugate radical. All right, so now we've got factors of h in the numerator and the denominator. It may help you to think of that numerator as h times 1 for the purpose of canceling here. So we're going to cancel a factor of h from the top and the bottom. And that leaves us with the limit, as h goes to 0, of 1 over our conjugate radical. So this is now the very first step in the problem where it makes sense to plug in h equals 0. So let's go ahead and do that. We don't need to copy our limit sign anymore, and we are going to plug in. So we've got 1 over x, or the square root of x plus 0 plus 5, plus root x plus 5. So really what we're getting in our denominator here is just 2 copies of root x plus 5. And that gives us our answer to the problem. F prime of x is 1 over 2 root x plus 5. So remember, f prime of x represents the slope of the tangent line to our original function f of x, and we could plug in any x value where this quantity makes sense to figure out the slope of the tangent line at that point on the curve.